you better understand that technicians need to know a modicum of math. And for acceptance testing, you've got to have some kind of a grasp of ratios and percentages. Otherwise, you're not going to know whether you're doing a good job. In fact, you will not be doing a good job. You will need to know how to calculate the percentage of power reduction achieved during testing. The percent reduction formula is used straight out for demand response for some entries on that form. So we're just going to do this one. And if you are sketchy on your math, you can just go get an old high school math book, because basically ratios and percentages are 5th grade math. And you don't need to go much beyond this to understand what you're doing or to check your technician's work. So, the main thrust of Title 24, Part 6 is power reduction. So we are going to determine how you calculate reduction, percent reduction between two illuminance levels, current readings, what have you. Let's take a look. There are two forms of this formula. I just decided to use this one because it seemed like the easiest one to remember, but it also seems like it's not right. So after taking this section, if you're thinking about it, walking across a parking lot a week from now, you might go, wait a minute, that can't be right. I guarantee this is right. We take an original amount, and then we do something to reduce it. And we take the total amount that we have left after reduction. And then we subtract that from the original amount and divide it by the original amount. And to make it a percentage, which is based on 100, it's a base of 100, we multiply it by 100 to make it a percentage. Let's explain. I have 3 things. I reduce them to 2 things. That's what I have left. Not how much I reduced it by, but how much I have left. When I subtract the 2, what I have left, from the 3, my original amount, I have 1. Divided by the original amount of 3 gives me 0.333, or 33% reduction, which is 1/3. I have 1/3 left. I started out with 3/3, and I ended up with 1/3. Wait a minute. Sorry. I started out with 3/3. I was reduced to 2/3. The difference is 1/3, and that gives me a 33% reduction. Oh, let me explain this a little further. I have 4 quarters in my pocket. I'm walking down the street. I have a hole in my pocket. I lose one of the 4 quarters. I get to the corner store and I pull 3 quarters out of my pocket. 4 minus what I have left, which is 3, is 1, divided by my original amount of quarters, which is 4, would give me 1/4, or 0.25, or 25%. I lost 25% of my money walking down the street. Make sense? Let's do it with pennies. I have 100 pennies in my pocket. I lose 25 of them walking down the street. That leaves me with 75 pennies when I get to where I'm going. 100 pennies minus 75 pennies, what I have left is 25 divided by my original number of 100 pennies is 25 divided by 100 is 0.25 times 100 is 25%. In either case, I lost 1 out of 4 quarters, or I lost 25 out of 100 pennies. I have a 25% reduction. Let's hope that makes sense. If not, just remember this formula is in your book and refer to it. This works with bird seed. I have 9 pounds of bird seed. Birds eat 1 pound of the bird seed, leaving me with 8 pounds. So 9 minus 8 is 1 divided by my original amount of 9 pounds is 0.111 times 100% is an 11.1% reduction. The birds have eaten 11.1% of my bird seed. Good luck. There's some other helpful formulas in the book, but these are a couple that might pertain to acceptance testing. For instance, if I want to know what 70% of something is, I divide 70% by 100%, I get 0.7, and I multiply it by the amount that I want to know what is 70% of. In this case, 70% of 40-foot candles is 28. The weird thing about percentages is they're different going up than going down. So let's take that same 40-foot candles and try and determine what 120% of that 40-foot candles is. 120% divided by 100% is 1.2 times 40 equals 48 foot candles. How about 80%? 80% divided by 100% is 0.8 times 40 foot candles equals 32 foot candles.